So I'm recapping how the grabbing of an object works. So when do we emit this entity grabbed? So this is sending the person that grabbed it, the thing, the ID of the thing I'm grabbing, the hand I'm grabbing it with, and the position and rotation of both the hand and the entity that I'm grabbing. So when so you need to construct a payload like this when you're grabbing something. So how do we know when to construct it? So to do that, we have a couple of classes that are instantiated when you enter XR, which means when we start up our server and enter a place, I'm going to enter a space. So when I enter this, I'm not in XR yet. I'm still not in it until I click on this thing. So this little widget here is created by the XR manager, but when you click on it, you actually jump into XR and things are created for you. So right now we don't have split view, for example, or we have to turn on the stereo effect, but we're not in it yet. So when I click this, this emulator goes into this split view, and then you can see I got new geometry. See, I see a left hand, a right hand, and a left hand, and I drew additional boxes by the hands in order to deter. I'm using that as an intersection. I'm using that box to determine if I've intersected with something. So that XR code is created by this class I wrote called XR Manager. And what instantiates XR Manager? Let's look for XR Manager. It's created by the Scene Manager. So in the constructor for the Scene Manager, which is created by Orchestrator, everything's created by Orchestrator, it has this listener that says when the client is ready, then instantiate the XR Manager, instantiate the default XR experience. This is what draws those pair of glasses there, and get this all ready. This client ready signal is fired when you dismiss those modals. So when we saw these modals come up, when I dismiss the third one, 1, 2, on this last one, that's what issues the client ready signal, and then that's what instantiates the XR manager and ultimately Babylon. We call a Babylon function which puts these classes here. Now when I enter the space, so we're going to jump into XR manager now. In XR manager, we are also listening for a couple things. Let's see. We are listening for camera movement. So this sets up listening around camera movement. But we also okay, so let's take a look at that. So this binds to when the camera is created, it has an observable that a callback that we can hook into, and then we say start emitting camera moved. Okay, so that's the head movement in VR, and this is all in the enable XR experience, which is it's waiting for the base experience to emit that message. Okay, so when we click on the glasses, I think that's when the camera will get set up, and when the camera is set up, then we will start moving. We will start tapping into camera movement. So likewise, we have a bit that sets up for each controller. So your left and right, so you have a callback for that. I mean, let me just check. When do we call this enable WebXR experience? Okay, so it happens when client is ready. So we're saying client is ready, enable the WebXR experience. It jumps over here, and then it creates the default experience. And I guess I'm just reviewing this code myself. Okay, so for every controller, you say on controller, and you add an observable, and you say, okay, run this code. So this code is going to run once for the left hand and once for the right hand because you have two controllers. Maybe in the future, if they have controllers for feet, it'll run there as well. But right now, um, the callback can tell you a little bit about itself, like whether it's the left hand or the right hand. So I kind of store this in case I need it. So I said the left hand is this and the right hand is this. So this class has properties of left input source and right input source. I don't think I'm doing anything with it now. And then I further do some initialization. And then in this initialization, um, we set up sending messages for anytime the hand is moving. And then we set up listeners for anytime buttons or the joystick or the grip. So these are called components, not to be confused with like React components or anything like that. But in the XR world, extended reality, these are called components, which are any kind of button pressing. So we're listening for those kind of things. And in both cases, we emit messages for those things. So the send hand position and rotation is here. It's simply listening on every frame, and then it is sending the position and rotation of the controller hand into a new signal that we have, which is called movement, left hand moved or right hand moved. And for the setup of the component, there's a whole list of things that you can get. So you can query for what are the component IDs, and then depending on the hardware you have, the component IDs of your device become like button A, button B, button X, button Y, joystick, grip, trigger. Those are the component IDs. And then for each one of those IDs, you can go and set up some subscriptions. So what I'm saying here is that for every kind of data payload that we get, pass this along, and you can get this kind of data. For example, when you squeeze on the Oculus Quest trigger, you can actually tell the difference when you're just touching it. So touched becomes true versus pressing it. If you press it hard, then press becomes true. Although if you're pressing and touching it, both of these will be true. If you're lightly touching it, press will be false and touch will be true. But then you can also get a value of how hard you're squeezing it. So this is a number between 0 and 100. So you could have some logic on this. And then accesses is the joystick. So I think that only applies to the joystick, but I thought I'd just include it for everybody. It'll just be 0 for X and Y if it doesn't really apply. And then you have the ID again of the component. So you can pass these things along. And these are passed as, again, left underscore squeeze, for example, or left underscore trigger, and then this payload here. So we're getting quite a bit of data in our internal message bus. So if we kind of look at the signal hub, these are the kinds of types that I've registered. So I created a new grouping called movement events, and look at the kind of rich data I can get, right? So I can, when you click on the glasses, you can get that the camera was moved, you can get that the left hand was moved. And I broke it down into all these signals. You can get like the left trigger, the left squeeze, left button, left thumbstick, left touchpad, which the Oculus Quest doesn't have one, but the specification allows it to have this. Then we have the same for the right hand, and then now I've started playing around with more complex events, like maybe the left grab start or the left grab released or end. I wonder if I'm using these. What happens if I comment these out? I don't see any compiling errors yet, but sometimes I can't tell. Okay, so I'm listening. I've set up listening to the hardware, and we're emitting these messages. Now it's just a matter of subscribing to these things. So, as part of this XR manager, when it is setting up listening for these kind of things, we set up position and rotation tracking. This is where the hand is. We set up kind of like button tracking. Did you press the squeeze button? And then I put up another bit of logic called the XR Grip Manager. This is a class I created to kind of listen for things emitted by these things and maybe make another layer of abstraction on top of it. So this is initiated once along with, the right hand is ready, left hand is ready. Do this one time. So let's take a look at the XR Grip Manager. And what this does is it's instantiated, and it instantiates some things of its own. So first it's going to say, okay, listen for when the left or right model is loaded. So keep in mind this class is instantiated once per hand. So when your hand is ready, I'm going to draw a box, a small box. It's only 10 centimeters tall, thick, wide, and then show its bounding box, and then take its visibility down to 0.5, which makes it kind of semi-transparent. And then I'm going to bind it to the to a certain position where it matches the input source's grip. So that's that light colored box that you saw when I was in XR mode. I'm drawing one of these for each hand, and I call this the grab mesh, because this is the mesh that I use to determine if I'm grabbing something. Then,
Well, is it gonna always be like a little mesh thing, or do you plan to like upgrade it to like?
I plan to upgrade it into a hand at some point.
Okay,
Yeah,
yeah,
like an
okay, cool.
animating hand or a claw, whatever it is.
I see.
And
Cool, cool.
right now I just need something simple. Then I'm gonna listen to Signal Hub, and I want to listen to this hand, which is a variable, because in my class I don't know if I'm left or right. So uh, I save that in a variable. Once this constructor could be used for either left or right, so I save my handedness in a variable. Then I listen to hand and then grip, which I made a variable. So I'm listening here for trigger. The reason why it's trigger right now is because this web-based XR emulator uses trigger. It doesn't actually use squeeze, but I have to remember to switch this around, uncomment this when I want to test in the Oculus Quest, because the Oculus actually produces squeeze, but the web emulator doesn't use squeeze. So in essence, this is listening for left squeeze or left trigger, which is one of my types. It's one of my types here, right? So I'm listening to one of these things to see if I am picking something up. So if you look over here, first we listen to it. Hey, I have a signal of it, right? And then out of that payload, which is a type of XR component, which I defined as this, right? Pressed, touched, all this kind of stuff. I actually only want the pressed, because when you grab something, I want you to grab it hard. So pressed is really all I care about. So here, I take that signal in, which is the XR component, has a bunch of things, and I say, I want to take that value and I want to map it into only the pressed. So now you're getting either true or false. And then as you continue to grib it, because the message producer is going to give you a different message per different value. Remember that here I said this thing could be a number between 0 and 100, right? So even as you're kind of holding it, this thing's non-stop sending messages. Like 99, 98, whatever. It's giving you a whole bunch of things. And I don't want that many messages over here. So I'm saying distinct until changed. First of all, we eliminated the value, and then we're only looking at true or false. And then I put on another filter which says distinct until changed. So even if you keep sending me true, 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 like you're holding, I don't care. I want the first true, and I don't want to hear from you again until it's false. So the only message that can come out of here is a series of true, false, for whether you're grabbing or something. So this is where RxJS observables are really nice for piping these values and transforming them. So now I'm going to subscribe to it. And squeezing will be either true or false. So if it's squeezing, we're going to check to see if you grabbed something, because you can squeeze out of the blue and be nowhere near something you want to grab, right? And then similarly, when you release something, I want to see if the thing that you're releasing is intersecting that thing, because you might grab something with your right, then grab it with your left and pull it away from your right. And then therefore, when you release on the right hand, you might want to unparent that mesh, but you shouldn't actually unparent it. And what I mean by parenting is when you know what unparenting is, right, Bobby?
Uh, in this context, it's just like determining which hand is the thing owner of the object or something. I don't know.
Okay. So
Oh, Babylon.
yeah, yeah. Parenting. Okay, let's say I move the sphere up, right? So I take the sphere, which actually is always moved up. You see how position Y is 1 meter up, and if it's 5 meters up, it just moves by itself. The ground didn't go into it because these two are not parented to each other. In fact, you can inspect it this way. See, the ground and the sphere are just siblings. But what if you set the ground parent to be the sphere? Where did it go? Ground parent equals sphere. I don't even see it. And let's put this back here. Okay, maybe I just need to play it again. So if this is 2, okay, so now wherever I move the sphere, the ground is, because the children follow their parent, in other words. So that's how I implement the grabbing, is that
I see.
in the check grab function, what we do here is first, I'm going to see if there's an intersecting mesh. Okay, so what does this do? So what this is going to do is, so ignore this part here. I'm just going to look at this. I'm going to look at every mesh in the scene that has a tag on it of interactable, because I don't want you to be able to grab everything in the scene. I only want certain interactables, like maybe a cup or a plate or a gun or something. Maybe those are the interactable things because I don't want you to be able to pick up everything. So those meshes have a tagging system. Babylon has a tagging system, and you can say this is an interactable. I made that up. So I'm going to look for all the things. So this is kind of expensive, but hopefully there's not that many interactable things. So I say, give me every interactable mesh in the scene. I'm going to loop through all of them and see, and this is the API that I have to work with, is that every mesh, every abstract mesh has a method called intersects mesh. You can check if one mesh intersects with another mesh. And this grab mesh is that cube that I drew over our own hand, which is parented to the controller mesh. So wherever I move my hand, that grab mesh is my palm, essentially. So I want to check against every interactable mesh to see if that mesh intersects my palm. And if it does, I just return early and I'll get that mesh back. And if it doesn't, then I'll return null. Now I was playing around with some other things because I got this part working and I was trying to add some other stuff, but I'm not finalized with the API. So anyway, that's the first part. Check, is there something? If there's nothing, so you gripped that grip button for nothing, and you're not by something you can pick up, just don't do anything, right? Don't do anything. But if it's not null, then we go down this path. Go away. Stop whining. Then I emit a message. So remember when I said what emits those messages? This is what I'm doing. So if you grip the button and you're over that thing, emit this payload, and this I create a method called create the event payload, and then we just fire it twice. We fire it outgoing, which will go to everybody else, and because I made it by default, the messages that you send to everybody else, you don't get yourself because I wanted to process it locally because I can process it faster than receiving my own message back from me with 100 millisecond delay or 50 millisecond delay or something. So I essentially send it to myself so that I can process it too. So what does this thing do? Here's the payload, which essentially just constructs this thing that I showed you before. It's saying who's doing the grabbing, what did you grab, where's your hand when you grabbed it, where's the entity where you grabbed it, and this is the hand that we're talking about. Okay, so we listen to this in Scene Manager. So we have all these listeners inside Scene Manager that manipulate the scene. For example, oh, member left, entity created, entity transformed, something was colored, entity deleted. Finally, we have entity grabbed, and then we decompose that message and we set the hand to where it's supposed to be. We set the thing you're trying to grab to where it's supposed to be. And finally, we set the parent. And so from now on, what that means is wherever your hand's moving, that mesh follows your hand wherever it goes. And that's pretty cool. And then you also have to track the entity released, which is going to do the opposite, which is going to unset the parent. So here it's setting it back to null. And the little bit of tricky business around releasing is that you have to check how you're releasing it. Is if I didn't check an intersecting mesh, what would happen is that let's say you grab something with your right hand, and then you're holding onto your right hand, so you're holding on tight. Then your left hand grabs it too. So that essentially allows you to pass something from your right hand to your left hand. That works fine. Grabbed it with your right, then you grabbed it from your right with your left. Now your left hand's holding it and your right hand's not holding it. But your right hand is still gripping that grip button, right? So that when you let go of that grip button, we generally want to say unparent, right? But then when you unparent that mesh because your right hand let go, but you're not actually holding it, what happens is that the object just becomes unparented to everything, which means that the left hand, which should be holding it, also doesn't hold it. So I don't know if you can understand what I'm saying is you grabbed it with your right, you pulled it away from your right with your left, and then you let go with your right, and your left hand also can't move it anymore. So to counter that, I just added this is that when you release, you can only release if you're holding onto it, and you're only holding onto it if you still intersect it. So if you're not intersecting it, there's also nothing we need to do. You're not holding onto anything. We don't have to emit any message. But if you are holding onto it and the um, the handedness, like this grab mesh, that intersection mesh, is equal to, in other words, the mesh that we found through intersection is already parented to our current grab mesh that says, oh yes, we are holding onto it. So then we can legitimately release it. And then we emit the message to everybody else and ourselves, and then that unparents it, it unsets the thing. So this was all working fine for grabbing an object, kind of rotating it between two hands, and then releasing the object, which there's no gravity yet, so it just stays in space. But I was taking it to the next level because I figured the next thing we want to do is actually be able to hold a gun. And you don't want to be able to hold a gun at a weird angle, right? When you hold a gun, there's a very specific position that you hold the gun in. And so I actually do not want to allow people to grab it in this manner, which is it just says, let's say there's a gun and you grab it in a funky position um, like a way you wouldn't hold a gun. Let's say you grab it at the corner of the top, right? You can't press the trigger that way. It seems unnatural. So this this grip manager stuff that I've written is really for manipulating other things like I don't know, a laptop, a pie, or whatever. The stuff that you can just sort of kind of turn around in your hands. But for a gun, I wanted it to snap into your hand, and so that's why I created another kind of message called entity assumed. So when it's an assumed, I think it becomes your hand. Like we could even like hide your hand. Your hand is the gun. So I was playing around with this concept, but the thing that I'm kind of struggling with is I'm not sure what the architectural design is because there are certain behaviors that are different. Like when you assume a gun, now we can't fully listen to these things anymore. Like we have to turn them off because it's constantly listening for a a squeeze to see if I'm grabbing something new or if I need to let it go. But if we assumed a gun, that kind of like defeats this. Like this isn't even in the picture anymore, right? We want to now process: are you dropping the gun or are you shooting the gun? Likewise for maybe a sword. Like maybe I pick up a sword and there needs to be other behaviors. Maybe I pick up some potion and then when I bring it to my mouth, I need to make some drinking sound. So there's like it feels like the architecture kind of needs to be able to have to be able to context switch between all of these tools. Like if you're picking up a marker or a laser pointer, your trigger does different things depending on what you picked up. It could be a paintbrush or whatever tool that we create. And so we need the ability to pick things up and assume their new abilities and turn off all the listeners for the stuff it can't possibly be. And then the second I drop the gun, we got to turn this back on because maybe I grab something that I need to kind of just turn around in my hands. It's not a gun. So I haven't quite figured out what that architecture is, but it seems like this is insufficient for handling that. I was also thinking about different modes because if you're in editing mode, you might want to grab something, and when you grab it with your other hand, instead of just like taking it from the first hand that grabbed it, when you grab something with two hands, maybe when you're in edit mode, then you get to stretch that object. So bringing your hands further apart kind of does this pinch and pull. And so, but so there's a lot of ways we could do this, but it gets overwhelming in how many features can Spider out there. So I need to kind of work on this part. So that's kind of where I am. Any questions?
No. I was just thinking like, yeah, how like I was yeah, just going through my head of how like some options of solving it. Like for example, if you grab the gun and it's upside down or something,
Yeah.
well, what happens right now in regular games? Like what if you pick up a gun when
Well,
it's upside down? Do you
you
remember? Like in
you
Arizona Sunshine?
you can't. When you pick it up, it
Mm.
snaps into your hand.
Oh, okay, yeah. So I was thinking something similar where let's say the object has like an upright position, like on its as a property, like whatever, like, and then whenever you pick it up, if this is an object that has like that, its property has an upright property. It's one if it's one of those objects that when you grab it, you snap it to that position, then like it would be something like that. Like yeah,
Yeah.
something like that. I don't know.
Yeah.
Just Brett, just
So
yeah.
I created a new kind of tag. So interactables are things that are generic. You pick them up and you can kind of turn them around in your hand. I call those interactables. And then
Mm-hmm.
I was having like things that snap into your hand. I called them assumables to say that your hand assumes this thing because that's how Rec Room does it. When you hold a gun, it doesn't even bother fitting the gun into your hand. It doesn't draw your hand. Your hand became the gun. So I think that's a pretty clever cheat because you don't have to worry about extra animation for your hand to hold it,
Oh, right,
which
right.
is I think it's fine. We can start with that. So I say so that's why I
Yeah.
call this like assumables. So I made a gun and I said this is assumable, and then you can assume this thing. But now I need to add other abilities because when you're assuming the gun, we need to listen for a trigger and then fire, let's say, a bullet and play some sound. So it's more about like code organization. Where do I put that and how do I make it compatible with other kind of weapons? But maybe that I'll just evolve that later. Like I don't have to come up with the perfect architecture. I could just make it work. But I wanted to these are kind of my next steps is I wanted to get closer on making Doom, right? So we need a gun. We need some so which is something we can grab, and then when the tool is assumed, you're holding the gun, we need to be able to trigger some kind of projectile fire message, and then everybody says that that bullet fired. And then I have to come up with logic like who's governing this logic? Like who determines um, when the monster is hit? Like does that happen in the client or does it happen on the server, which would be slower? Or maybe because I'm the one that shot the bullet, like I'm the one that says whether they hit or not, and then I tell everybody else. So I haven't quite figured that part out.
I see. Yeah, the work to be done.
And then we have to create the monster, and we have to figure out how to make the monster come at you, come to you. Which it can be a box, but the box still has to move to you and avoid obstacles like walls and things like that. So, which I think Babylon JS actually has something for that. It's called pathfinding. They can actually do that already.
Oh, cool.
Okay.